Hello everyone, it's 1 p.m. Eastern, and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. Thanks for joining us today. I'm your host, Henry Regis. My regular co-host, Nolan Duskin, is on travel this week. Actually, he's in our nation's capital. And also with us today, running the show behind the scenes, are Zach Schwalbe and Noah Newman. We're coming to you live from the Colorado Climate Center here at Colorado State University in sunny Fort Collins, Colorado. Today we're going to explore the topic of historic winter storms and look at some of the biggest ones on record. For those of you who are unable to join us for our live broadcast, we're recording this one for future viewing, and you'll be able to see that on our website. All of our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. Well, we're excited to have with us today Paul Kocin. Paul is currently a winter weather forecaster at the Hydrologic Prediction Center located at the National Centers for Environmental Prediction at their new location in College Park, Maryland. Some of you may remember Paul as the winter weather expert at the Weather Channel, or you might know him as one of the authors of the AMS book on Northeast snowstorms, which he co-wrote a few years ago with current NCEP director Louis Ussolini. Paul is a native Long Islander and has experienced many winter storms during his life along the East Coast. Welcome, Paul. It's a great privilege to have you with us today on our webinar.
Well, thank you very much, Henry. It's also it's a pleasure as well, and it's nice to be able to talk to members of CoCoRaHS because as a member of the meteorological community, we really appreciate the work of our weather observers, without which we would not be able to get a real accurate assessment of what actually goes on. So it's really nice to be here. And the title of my talk is Historic Winter Storms, and it's a little bit of a problematic title, especially since it's called The Best of the Worst. And it's problematic just because I'm being a little bit lighthearted that some of these events in particular affect life and property. And you know, they're serious situations that require a lot of concern and response, actually, from the emergency response communities. And I don't want to make too much light of them, but I know, as many of us who have gotten into interest in the weather, it is really these big events, some of them historic events, in particular with winter storms, that have gotten our interest into the field going. It certainly got into mine, and I'm assuming with all the people that are on here that you also got into the weather primarily because of your interest in some of these events. And since I did take notice of a response to some of my questions, a lot of you have remembered some of your big storms, and many of them have in fact been winter storms. So I have a bias towards the East Coast, but I will try to be explaining some of the reasons why and how these systems develop. The emphasis will be on the East Coast, but I'll also take some of the historic events through different parts of the nation as well. So this talk, again, will attempt to explain some of the hows and whys, some of these particular winter storms. On the picture here is down in Washington, D.C., after the Snowmageddon and Snowpocalypse storms back in February 2010 occurred. And I'm going to focus on the East Coast as well, my area of greatest interest. But I've done some quick changes, seeing the makeup of the audience today, just to make sure I'm not leaving too many people out of this discussion. So in particular, for different parts of the nation, historic winter storms often mean different things depending on where you are from. In particular, where you particularly grew up, which often forms our interest in the weather. For example, in South Florida, it would be one time it did snow. That's back on January 19th, 1977. This is actually in Tampa, Florida, which has had a few other events. But if you were from someplace, say Miami Beach, that is the one time where a historic winter storm basically meant it snowed for the first time. Now, on the other side of the coin, if you're from Alaska, in particular if you're from Valdez, Alaska, if you have 2 feet of snow in any one particular day, that's not such a big deal in a place that averages 300 to sometimes more than 500 inches per year. Now, where I grew up, it's an area that really only experiences maybe 20, 30, in some places 40 inches of snow per year. Some seasons we don't see any snowstorms, In other seasons, we might see a few. But in general, on occasion, some of these storms are what certainly got me into the field, and some of them have become historic. And what's interesting about this particular slide, this is a photo I found on the web. It was actually taken in my hometown of Syosset, New York, after a storm or a series of storms in 1960-61, where the snow was incredible in depth. And actually, I can tell you, my memories of this particular storm back in February 1961 are one of those memories that got me into the field and got me to do what I've done, which is write books and really focus in on some of these storms. And I'm looking at this mother and child looking out the front door, and those are called jalousie glass doors. You can move those glass panels up and down. That's actually kind of like my house. That's what I was doing that particular morning, even though I could not get out the door. So I was a kid one time, many, many years ago, and as a kid with many hobbies, and I can go down the list, but I won't. The one that kind of stuck with me was right at the bottom, not the one with burning ants. That one has passed a long time ago, where I liked the weather enough that eventually that stuck with me, and that's what I did. My father and mother used to tell me about some of the storms they lived through that really piqued my interest. And here's a picture of what had been New York City's greatest snow back in December 1947, more than 2 feet. You can see the man in the lower right, not a friend or relative, but it was an evocative picture of somebody going, oh my God, what is this? I needed to know more how those situations occurred, such as the map on the left. What made these particular storms bigger and better than most? And it also piqued my interest because I lived in an area where millions of people live, so the impact of these storms were particularly great. So, being the kid that I was with all of these hobbies, what was I going to do? Well, I started looking at the New York Times weather maps, started cutting them out, started notating them. I was a little bit of a weird kid, but I'm sure there's some of you out there that might have been the same. Weirdness is not a bad thing. And I started a weather diary, and lo and behold, many years later, I found out I was not alone. I got together with another Long Island snow fanatic. This child at the time was a young Louis Uccellini. This is back in the 1950s. You can see he was doing things similar to what I was doing. He's currently director of the National Centers where I currently work, and we have actually written a number of books together. First one was published in 1990. The second one, I had twins, or we had twins, called Northeast Snowstorms. I think Henry will be able to tell you where you can actually be able to purchase if you are so interested. And this was published back in 2004. I'm actually working on a volume 3 right now, which will encompass everything after the year 2000, as well as some of the new science that has occurred and progress that has occurred in forecasting winter storms since the last books. And all of this is basically about how did the most historic storms of my childhood and sometimes before that occur. And as I was looking through some of the write-ups from some of the people who were attending, I did notice that there was someone who said his most memorable storm was from the New York City snowstorms of the winter of 1938. So some of you go back quite far. Some of you, assume, are much younger. And I'll try to pique your interest as these have piqued my interest as well. So a brief background, let's start really simple. I'm not going to get too complex. But basically, where I'm from, East Coast snowstorms come in 2 general flavors. This looks like vanilla and strawberry. I'd rather see chocolate. But in general, they can be divided into either what we call classic nor'easters or those storms we now call secondary development or redevelopment. In general, the classic nor'easters are those storms, if we're sitting up on the East Coast awaiting something interesting to occur. We often see these a few days in advance. We'll look on the weather maps, we'll hear the news reports, and we'll see there's some storm brewing in the Gulf of Mexico. It attempts to move up the coast, and lo and behold, we get them and we see them coming, and they'll hit really powerfully. That's if we're lucky. Again, you'd think this happened all the time. This actually is a relatively rare occurrence. And this is what they generally look like on our surface weather maps. You can see on the top 3 panels, that's the blizzard of 1966. On the bottom panels was a wonderful winter in my impression. This is a snowstorm back in January of 1978. In both cases, we can see low pressure developing in the Gulf of Mexico, moving northeastward, and the isobars, or the lines of constant pressure we see on the maps, get more and more close to each other, indicating they become more intense. And in general, the more intense the storm, the greater the chance they have of being what we call historic, because often the precipitation is heavier, the winds are stronger, and the impact is therefore greater. The other class of storms are called secondary developments. Sometimes with these, at least they will develop initially from the northern plain states, what are called, say, Alberta Clippers, or come across the plain states, say, from Colorado moving eastward, or even from the Gulf, but they move towards the Ohio Valley. The main thing that keeps this set of storms together is that the storms often die out at the expense of a new storm system developing on the East Coast that can suddenly develop quite rapidly. These cases often were a big problem for forecasters because we often did not see them coming, but it's not usually so true now that we have some pretty good models that see things several days out in advance, which was another question I asked in the registration for the course. Here's some examples of 2 different cases back in 1960 and 1961. As a matter of fact, the storm system on the bottom was the one in which the picture was taken, which showed my hometown all those years ago. In both these cases, the storm actually moved from the Gulf of Mexico or the southern plains towards the Ohio Valley, and then that low pressure area died out, but then a new low pressure system developed on the East Coast and developed into something very strong, very intense. So why do they develop like this? Why do we get these storms in particular? I mean, the storms happen all over the place, but why is my fascination there with the East Coast in particular? And it basically comes down to something that's relatively simple in terms of how the atmosphere works during the wintertime. What happens in the winter, the land, as the sun becomes lower in the sky, the land tends to cool faster than the ocean because the ocean tends to hold the heat much more readily than land does. That by itself creates a difference in temperature or temperature gradient that is maximized along the coast. Therefore, the East Coast becomes the channel along which these storms can form. So that seems pretty easy too. The reality is, if you've grown up in the big cities or around the big cities of the Northeast, most of these storms, when they do form, occur as rain. In Washington, D.C., for example, only 10% of the precipitation in winter falls as snow, only 15% in New York, and in a place like Boston, which averages about 40 inches of snow per year, even here, most of the time, 75% of the time in winter, most storms will produce rain. So that's not very high. So snow is not that common, but occurs often enough that it becomes a big deal. So why is that the case? What often happens with these big storms is that they have to be associated with a high of Arctic or Canadian origins that brings down the cold air. So while the storm systems or low pressure areas themselves bring up the moisture, actually bring up the heat that tends to favor the development of the storms, high pressure brings down the cold air, and it's the combination of the two that creates these narrow channels of high temperature difference and large moisture where we infrequently get these very big storms. And again, notice that the maps of these 2 very big storms I just talked about both involve big storms and big areas of high pressure. So that's what we often see for some of these big storms. Here are just 4 other examples of big storms in the Northeast with a very, very similar pattern of low and high pressure. So, it's that simple? The answer, no, not really. It is the evolution of many more processes that are much more complicated. I won't be going into that because I want to keep things simple, and I want to go towards a description of some of what these big storms actually wind up to being. So you put these storms together, to 50 to 100 million people that live along the East Coast, and sometimes you get something truly historic that impacts huge numbers of people, often for several days, if not for a week or longer, that have occurred a number of times in the past as well as relatively recently. Some of these storms are told in family stories and are likely to be remembered for generations. And this talk will actually end, and I'll describe some of the aspects of Superstorm Sandy that, while not a traditional winter storm, actually came into play and became historic because of some of the factors that are important for some of the winter storms that we've seen as well. So for historic storms, a couple of factors come into play. Usually the storm has to become unusually intense, either by very low pressures or large differences in pressure between the low and high pressure center. Or number two, the storm has to last longer than a typical coastal snowstorm, often lasts 12 to 18 hours. Some of these storms last 1, 2, and in rare instances they can go on for three or more days. When meteorologists see what we call a blocking pattern setting up in the atmosphere, this is often a time where very intense storms that don't move much become possible. And that'll play an important role in some of the cases I'm about to describe. The block is set up in the atmosphere in a way that we often experience as meteorologists who live in the northern hemisphere. Weather moves from west to east, and normally it continues along on its merry way, but sometimes the west to east flow is obstructed when a system cuts off from the main flow. What we're seeing in the image is that in cases where we actually see in the East Coast, we'll see what's called a blocking high that might develop over the North Atlantic, and then systems coming in south and west of it kind of get clogged up, and when they do, the atmosphere gets really out of balance, out of whack, and something needs to happen to restore that balance because, in a sense, it feels like something is amiss. So the analogy is a car that gets stuck. Everything behind that car backs up because of the block, and in order to get things moving, that block has to be released by something that occurs, usually involves the police, the fire department, whatever, time of day. The atmosphere works a little bit different than that, but the reality is that it's an imbalance that has to be released, and that imbalance often takes the mechanism to get the, actually it's a huge storm that's the mechanism that gets the atmosphere quickly back into balance. These storms are often the extreme examples of what I just showed, and in several but not all of the cases, blocking played an important role in making these events particularly extreme, and that occurs even in the recent case of Superstorm Sandy. All right, so now to the best of the worst, at least in my head. This is a picture taken, a very nice picture taken back in the 1905 era, back in New York City, when things were a little more quiet. Don't see too many cars and buses and taxis, but this harkens back to an easier day where some of these storms were important, and one of them that was probably the most important across the Northeast back in the early days was the legendary blizzard of 1888. And on the right-hand side, I have some of the original weather maps shown for the period, as well as a local forecast that was issued from Washington, which actually shows that the forecast with this system was just basically rain and a cold front followed by clearing weather. What actually happened was an extreme snowstorm, many deaths, last 2 to 3 days, heavy snow, temperatures falling into the single numbers, accompanied by very high winds. It also resulted in my first professional article back in 1983, where the job that I had was basically to reconfigure, figure out actually what occurred, take all the surface data that actually did occur at the time, and reanalyze the maps. And the maps were there, and the maps do show the picture of what actually occurred, in that it was a slow-moving storm, and generally it was rain changing over to snow, which is not that common in places like the Northeast. It's very common in places like the Rocky Mountains, where you'll get a cold front come through, and then lo and behold, it gets colder, and then the snow develops, and the temperatures kept dropping. In this case, if you look on the right-hand side, we see a sequence of weather maps where we have a cold front moving from west to east. One low moves up into Canada. The green represents rain. It started to rain. Nothing particularly unusual like that. but then a low on the middle left panel develops over the southeast, moves up along the cold front. What was strange here, that the front to the north actually continued moving east as well. The storm then developed to the top right, set off the New England coastline for days with this very strong front on one side, enhancing the snowfall rates and bringing temperatures increasingly colder from that large high-pressure area north of the Great Lakes. So temperatures basically fell from the 30s through the 20s, through the teens into the single numbers, accompanied by gale force winds and what appeared to be never-ending snows. Some of those snows, if you look on the left-hand side, amounted to 20, 30, 40, in even a few areas as much as 50 inches of snow near Albany, New York, especially across south central Connecticut. Some of the pictures from the era, this is a picture from Wall Street. That's a pretty impressive scene. Another image taken from Brooklyn, New York, very nice. Again, this is almost 125 years ago. And the last one is actually a photograph that I have framed in my own house. Again, describes the kind of person I am. This is a picture taken in New Haven, Connecticut after about 45 inches of snow. In those days, they used to shovel the sidewalks, put the snow in the street. That was more important than clearing the roads. So blizzard of '88 wasn't unique. Yes, unusual rain to snow situation. It was definitely unforeseeable. They certainly didn't forecast it then. Without models, chances are it would be difficult to foresee now. With models, chances are, and we haven't been able to run this, although we've gotten better at this, there probably is an ability to reproduce this forecast and show that it probably would have been predictable, at least to a degree, with today's models. Then we go from 1888 to 1899. So what's the difference here? This one was different from that case in that it was not quite just an East Coast weather event, but to kind of get you started on this one in terms of historic events. I don't know if many of you remember the idea of having ice flows move from the Gulf of Mexico down through near New Orleans into the mouth of the Mississippi into the Gulf of Mexico. I don't remember seeing anything like this in my experience. Do you? Well, here's just a couple of pictures taken from the aftermath of that storm. Top left, New York City. Bottom right in Washington, D.C. We haven't seen snow like that, well, since 2010. We've actually seen similar kinds of snow in the last few years. But before then, we'd have to go back to 1899 to see snowfall on a level of about 3 feet. So in terms of snowfall across the Northeast, it was your classic heavy snow situation. Blue represents 10 inches or more, dark blue more than 20 inches, and a few places, including Cape May, New Jersey, the big winner, at 34 inches of snow. So, you know, historic-wise, we've seen storms similar to this. This is definitely one of the top storms, but what makes it unusual is not necessarily what just happened in the Northeast, but what happened elsewhere as well, especially in the southeastern United States. Notice that the snow goes all the way down to the Gulf of Mexico, as well as down the peninsula of Florida. Now, in Florida, we've seen snow as far south as Miami, but prior to that case, this case was actually the farthest south it had snowed prior to 1977, and that was at Fort Myers back in 1899. And I'll show some other interesting things about this storm that chances are we're not going to see something like this these days, simply because we certainly haven't seen these kinds of temperatures in many, many years. So here are the weather maps over a 12, 24, 36-hour period, go from top left down, top right down, on the 11th or the 12th and 13th of February 1899. Now the numbers I have on the maps are temperatures. Those temperatures are not in Celsius, they are in Fahrenheit. And if you look on the top left, you'll notice that places like southwestern Missouri, 28 degrees below zero. Dallas, Texas, 8 degrees below zero. There's one storm, low pressure system moving off the East Coast. Temperatures are in the single numbers with snow, while down across the southeast, it's heavy snow, 10 degrees in Atlanta, and perhaps for one of the only times in history, near blizzard conditions in northwest Florida, Pensacola, New Orleans, Louisiana, although they had a huge storm just a few years before this. And over time, that incredible mass of cold air across the southern United States continued to plunge farther, that by morning on the 13th of February, that's the panel on the top right, it went down to 2 degrees below zero, the only sub-zero temperature ever recorded in Florida, Tallahassee. It's 7 degrees and windy in New Orleans, and it was about 8 degrees below zero in Atlanta, Georgia, which hadn't been approached again until 1985. At the same time, this huge storm was developing up along the East Coast with temperatures only in the single numbers with this incredible storm. And if you even look farther down across the Florida Peninsula, check where Tampa is. That's the station with 29 degrees and light snow. They're getting Gulf effect snow off the Gulf of Mexico because of the cold air passing over the very warm waters of the Gulf of Mexico. I haven't seen also that happening too much recently. So going forward, the Knickerbocker snowstorm in January 1922 is historic, not because of necessarily the heaviest snow in history across Washington, D.C., which it was, 28 inches officially. Some of the heaviest snows above 30 inches, as shown in the bottom left, occurred near or around the Washington area. But unfortunately, with this case, it led to the destruction of the Knickerbocker Theater, one of the few places that was open because people wanted to escape the winter storm and at least go to the movies or go to the theater. And what happened was the snow caused the top of the theater to collapse, killing about 100 individuals. That said, it was another classic storm. If you look on the right-hand side, there's your cold, excuse me, cold high to the northeast United States with your storm system developing along the mid-Atlantic coastline. And excuse me just a second, I will wet my whistle, with water that is, and go on to another part of the country where one of their worst storms on record occurred in November 1940, the legendary Armistice Day blizzard. And the story is it was a rainy day across Minnesota, and there were a lot of duck hunters out there doing their thing, shooting down ducks and getting their meals late in the season before wintertime really began. And during the day, that rain changed to an incredible mixture of heavy snow and high winds, as indicated in the top two panels, and also produced some horrendous conditions out on the Great Lakes, resulting in a lot of loss of life due to shipwrecks. So, and here's the original weather maps from that case, a system developing basically along a fairly typical path in southern Colorado, and then moving up to the northeast. The following morning on the 11th, it's a rainy morning in Minneapolis, but the storm is just to the south, and it really spun up, and rain changed to snow, and winds picked up, and the rest is history. One of the most famous storms, and one that they actually compared Superstorm Sandy to, was not a hurricane, but an extratropical storm called the Appalachian storm in November 24th, 25th, 1950, about 60-odd years ago. And this storm has always piqued my interest because looking at the weather maps, I don't think I had seen anything quite as dramatic from a weather point of view as this particular storm. So what did it do? It did as in Hurricane Sandy. Here's LaGuardia Airport, which flooded in Hurricane Sandy. Here's LaGuardia in 1950, also flooded, probably not quite as severely. This storm was accompanied by over 100-mile-an-hour winds in the New York metropolitan area, and that was not the only area that received those kinds of winds, as well as a coastal surge. That coastal surge was important, but not as big as Hurricane Sandy, simply because this storm moved much more rapidly and developed rapidly, that conditions occurred quickly and then they died down. It still was very severe. Did it produce snow? Oh, did it produce snow. Here's a map of the snowfall. Most of the snow obviously was west of the major East Coast cities. The effect was more similar to Sandy in that it was in West Virginia, but it was across much of the eastern Ohio Valley with the heaviest snow of 30 inches more across western Pennsylvania and much of West Virginia. I think the maximum snowfall with this case was about 62 inches, but it did last about 4 or 5 days. Nonetheless, it was quite a storm. If we look at the weather maps, I called this storm of the century for last century. And the specifics, in terms of blocking, you can only infer it from this particular case. It starts out on the top left as another cold front, but instead this was record-breaking cold air for late November. The temperature actually dropped to about 5 degrees in Atlanta, Georgia in late November, below zero through much of the Midwest. This was unusually cold. But at the same time that this cold air outbreak was occurring, the block was occurring, as it did with Sandy, over the northeast United States and southeastern Canada. And an indication of that block is, look at the sea level pressures north of New England. Look in the top panels. Those pressures were rising as the storm system was developing over North Carolina. So if you look at the bottom left, there's the low developing in North Carolina, and there's the pressure rising northeast of Maine. That high pressure area was stuck because of the block. As a result, as that storm system developed in North Carolina, began to move northward towards Washington, D.C. in the top right panel, the block held in place. The difference between the low and high pressure caused the pressure gradients to increase, such as the winds increased, and the storm itself could not move except in one direction, which was to the west-northwest. That in 12 hours, it wound up going from Washington, D.C. to near Cleveland, Ohio, and then eventually wrapped around itself, moving south into central Ohio. That's the same kind of sequence that we saw with Hurricane Sandy in the case of these huge blocks. So this is an example of a big storm developing in a block. That block helped it become a historic storm. So looking at it in a little more detail, the conditions that set it up, these are some closer weather maps. If you look on the left-hand side, early in the morning on the 25th, notice that it's in the single numbers. Those are temperatures across West Virginia. While east of the front, cutting across the middle of Pennsylvania and Virginia, it's in the 50s with increasing winds out of the east and southeast as the storm was beginning to develop over central Virginia. 6 hours later, we know that low pressure area moved north across D.C. to southern Pennsylvania, and a new center developed across northwestern Ohio. What's interesting, well, there's a lot of things that are interesting. Winds across western Pennsylvania changed to the south as high pressure built in from the south where the cold air was, and temperatures in Pittsburgh fell from 20 degrees to 9 degrees on southerly winds. Same time it's 9 degrees, in New York State, temperatures are rising into the 50s on increasing easterly winds. And notice those flags on Long Island on the right-hand side represent sustained 50-mile-an-hour winds. On another side, if you're in Detroit, Michigan, you see the warm front to your east. You're starting with a big snowstorm as the storm is to your south. That warm front would eventually pass from the east. Their winds would go over to northeast. Temperatures would rise into the 30s. And then eventually, the cold front would move also from the east and come across Detroit, change them back to snow as their winds went to southeast. So you got that? Very confusing weather situation. We often see things coming from west to east. Cold air comes from the north, not from the south, but this turned everything up on its head, and the result was an incredible snowstorm across the Appalachians, record rains, incredible winds, not only in the New York area, but all across New Jersey, interior New York, and much of New England reported winds of 80 to 100 miles per hour. Now, why didn't this produce the kind of flooding that they saw in Sandy? Sandy developed over several days, a huge circulation, much like this storm, but this storm moved through relatively fast. So the ocean could not respond for quite as long a period of time to the incredible conditions that they did to Sandy, which is why they had very bad flooding, but not record flooding with this storm. That's small consolation. So it's very unusual. How unusual is it? Has it ever happened before? Well, it turns out there's another incredible storm back in 1913 that got the name of Freshwater Fury because of all the ships it sank on the Great Lakes. And what we see is a storm system much like November 1950. Produced record snows in places like Pittsburgh and Cleveland, and a low pressure system that moved first towards the north and then moved towards the west undoubtedly as a blockhead set up just as it had in 1950. So, not to keep Pacific Northwesterners, I don't know if that's the right term, out of the loop here, they had their winter storm, not particular in terms of snow and ice, but in this case was very strong winds back in 1962. This is their storm of record. Lots of trees down, incredible amount of damage to property. I don't think there's been anything before that or anything like it since. The map on the right-hand side shows maximum wind speeds well over 100 miles per hour on the coastline, but even across the interior. A place like Corvallis, Oregon, where the University of Oregon is located, 127 mile-an-hour wind gusts, with the storm system depicted in the analysis over there, one of the most intense storms ever experienced in the Northwest. And while looking at the storm, I ran across the local weather station observations from Corvallis that showed, as you're looking from top down, a fairly interesting storm with winds of 25 to 35 miles an hour. And then as we get towards the end of the panel, winds actually died down, briefly reaching calm around 1400 GMT. But the next observation past that 1400 GMT time was 2 hours later, where winds go to south-southeasterly at 60 to 85 miles an hour, gusts to 110 knots. That's about 125, 130 miles an hour, with the connotation, abandoned station, instruments destroyed. So this was kind of a big deal. That's what's called historic. Another storm for the Ohio Valley occurred while I was going to school in New York State, called the 1978, some call it the Cleveland Superbomb, others call it the Ohio Valley Blizzard. Incredible storm, temperatures dropped to near zero, if not below zero, accompanied by hurricane-force winds and record snows. And this was one of those cases, using the daily weather maps, where it's a combination of weather systems merged or phased together, where sometimes what happens, weather systems merge together, they become lesser than the sum of both. In this case, they became far greater than the sum of the two systems and developed into an absolutely huge storm system. Much like 1950, another case like 1950, like 1913, warm air moving in crazy directions out of the north, coldest air coming in from the south at 0 degrees in Indianapolis. It's in the 20s across Michigan, not quite as extreme as 1950, but the impact was definitely huge. And here are some of the impacts of that storm that some of you from the Ohio Valley, whether you're from Ohio, Michigan, Indiana, Kentucky, might remember. Such strong winds, blowing and drifting snow that you can see the drifts on the house in the lower left-hand panel blowing from the top of the house all the way to the ground. A week and a half later, New England experienced one of their worst storms on record, the New England blizzard of 1978, just coming also not only after the Ohio Valley storm, but 2.5 weeks after a storm that for Boston was their heaviest 24-hour snowfall that was broken by this storm only 2.5 weeks later. 20 to 30 to 40 inches, some would claim it was more, but the most interesting thing about this case was that it was accompanied by hurricane-force winds and another case with incredible coastal flooding, probably the worst storm on record for eastern New England. And here's some of the weather maps for that storm. Just to give you some perspective, this was an example where a 3-day forecast actually predicted the storm back in the late 70s. At the time, that was an incredible prediction. Forecasts of winter storms, only 1, 2, and 3 days. 3 days would have been the absolute max. We didn't really believe it simply because forecasts were not verifying at that time. Also, one of those cases, we didn't see it as far as looking at the maps coming, in a sense, because there was no big storm in advance, no storm in the Gulf of Mexico, just a little bit of snow and a small low pressure area across the Midwest, and then it developed off the East Coast into a bomb where it almost had hurricane characteristics, although no deep convection at the center. 10 years later, if you're across Minnesota, you're no stranger to heavy snows, but the Halloween blizzard of October 31st and November 1st, 1991 occurred basically on the same day, the same couple of days as another storm called the Perfect Storm was battering much of the East Coast with not so much wind and rain, but terrible coastal flooding as a huge storm stayed offshore and produced the kinds of flooding that they worry about with storms like Sandy. In this case, the storm was developing across the upper Midwest, 28 inches of snow in Minneapolis, 38 inches of snow in Duluth. Both of those cities all-time heavy snow records. So for them, this was a historic winter storm. We go back 19 years ago, the March 1993 Superstorm, very historic case. Why? Never before, at least in my experience, has there been so much snow fallen over so large an area. So if you look at the map on the upper left-hand side, you'll see the black line represents everything greater than 4 inches of snow. Blue, as I've discussed in other cases, snowfall 10, 20, 30 inches and greater. Never has a storm produced that much snow that affected that large an area. This storm really severely impacted about 100 million people over several days, kept schools closed. Even in the big cities in the Northeast, it was a snow-changing terrain, probably the worst snow-changing terrain event on record, because the snow changed terrain after about a foot of snow fell. And just like in Hurricane Sandy, a huge circulation. Here you can see, particularly at 12Z, 7 o'clock in the morning on 13th of March, very deep 970 millibar low pressure system, deepened actually 960 along the coast of Maryland, with a huge circulation covering nearly all of the eastern United States. And I give those pressures just to put a little perspective on what we'll see with Sandy coming up in a few minutes. Before that, we'll get to the blizzard of 1996 in the Northeast, one of the largest snowstorms on record for the big cities, generally 20 to 30 inches anywhere from Southwest Virginia up to Southwest New England. I was lucky enough to be in Washington for this. And if you remember some of those depictions of what a classic East Coast storm looks like, blizzard of 96 is your poster boy for classic Northeast snowstorms. In Colorado, you've experienced obviously many, many heavy snows over their history. I was working with the Weather Channel during this, and I just remember, if you look at the satellite picture, on the lower right-hand side was this incredible plume of moisture coming up from the Gulf of Mexico around this upper-level low-pressure system, right smack into the Colorado Rockies. In Denver, 32 inches of snow, their second greatest, and to the northwest or west of Denver in the mountains, as much as 87 inches of snow. Again, not the biggest snowstorm on record in Colorado, but certainly one that, at least over the last 50 years, has to really rank up there as one of the best. As we get towards the near future, or the more recent times, a storm we now know as Snowmageddon. This figure right here represents reality, a real-life analysis of what happened on the morning of February 6, 2010 on the right-hand panel. And on the left-hand side is a modeled forecast, the European Center forecast, 8 days in advance. That forecast was made on January 28th. And one thing, even if you don't have a lot of experience with models, and I'm sure some of you do, that's a pretty good forecast. I was going to use a little bit of a cuss word, decided against it. You can imagine what it was. It wasn't too bad. That was an excellent forecast. Our American model, the GFS, came on board on day 7. So it wasn't just that one storm. And here another case of a slow-moving storm developing in the Gulf of Mexico, big high pressure to the north. What was really interesting that this storm by itself would have remained historic because of the 20 to 30 inches of snow that fell across the mid-Atlantic states. But even as the storm was going on, the models were actually showing another storm 4 days later. That one was perhaps called Snowpocalypse. It gets a little ridiculous, but let's just call it for that. And this is the 12-hour sequence of maps. Not the same, it's more a case of a secondary development case where system comes through the Ohio Valley and then a low-pressure system develops along the eastern seaboard. How much snow? Whoop! I was here for that one. across the Washington metropolitan area, Baltimore metropolitan area, 40 to 50 inches of snow in the northern suburbs from those two storms. We're talking about blizzard of 88 type snow totals with that. Historic, oh yeah. Here's the actual radar data for Snowmageddon in the top left, Snowpocalypse on the bottom right. On the top left, we just see the band after band of snow. Some of those red represents the rain snow line, got perilously close to the Washington area, but it did not pass through the area, and then the bands go as the storm moving off to the northeast. We get on the northwest side and the heavy bands of snow there. Looking at the bottom right-hand side, definitely a different kind of development. Echoes moving from the south. Again, those bright bands represent the rain-snow line, but a deep storm coming in the upper atmosphere causes the secondary low to really explode off the coast. That we're seeing right now as those bands are developing from east to west as the low is developing offshore. So that was our 1-2 historic punch back in 2010. That was followed 2 weeks later by another case that wasn't bad in the Washington area, but did dump 20 inches of snow in New York and up to 40 inches in the Catskills. And this storm actually kind of gets lost in the fog of all the storms that occurred not only in 2010 but well into 2011. And the reason I'm bringing it up here is because I still have this little bugaboo about Sandy, that it was a once-in-a-lifetime, a very unusual track with very few precedents. Well, this one storm in late February 2010 did occur actually in something similar to Sandy, in that we had a storm that moved from east to west. Again, I don't want to say that it's common, but there have been a few times. So if you look at the weather maps for this particular case, the satellite images are on the right. Low pressure develops out over the Atlantic. It moves towards eastern New England, and then over time passes near Nantucket, and then moves just to the north of New York City. We can see the motion on the radar image on the bottom center here. Here comes the low pressure area moving over Nantucket, then moving due west. And it's the one time I can remember where I saw heavy snow across Long Island, which typically occurs on northeasterly winds. Actually, some of the heaviest snows fell on west to southwesterly winds as the storm system passed to the north. And that takes something really unusual, like a block, to get that going. So we ended now with what just happened a little over a month ago. It was sort of a winter storm. It was definitely historic. Top left is the water spilling into the World Trade Center site, and the bottom right is an image taken on the Lower East Side of Manhattan. And let's first look at the figure on the bottom right, which shows all of the hurricane systems that affected New York over the past, say, 100 years. You'll notice virtually all of them come from the south, move due north or slightly east of north, and really pose a big threat for any sort of perpendicular coastline, which would really mean the coast of southern New England. It might mean Cape Hatteras. These storms are moving south to north. One storm that does hook around to the left, but not before it actually moves basically due north, is the hurricane of 1938. And there was this one little storm in New Jersey, not a particularly intense one, that does move to the northwest. Meanwhile, Superstorm Sandy, extremely different. I used to draw this as a kid like, oh yeah, this is going to happen. The only way you're going to get really intense hurricane conditions is for a storm to come in perpendicular to the East Coast. What would that take? It would take a ridiculous pattern that we almost never ever see. That's a storm moving from east to west or southeast to northwest. And that's exactly what Sandy did. So, latest I've seen, here's the track on the right-hand side with the rainfall analysis done by Dave Roth. Most of the heaviest rainfall fell along and west of the track. And since west of the track, now you have to kind of go on your head, fell south of the track because it was moving west. Not that much rain actually fell to the north. Damage estimates are now $60 to $80 billion, mostly in New Jersey and New York. Yesterday I actually saw an estimate that said the damage was now up to about perhaps $100 billion. That's not all that much less than occurred in Katrina. And the rare turn to the left resulted in a surge threat that's rarely ever experienced. Why? Because storms just mostly don't do that. It was one of the deepest lows ever recorded off the New Jersey coast, and here's where I say, remember that value of 960 that came during the March 1993 superstorm? This one was better, worse, best of the worst. The turn was due to an interaction of a significant winter-type event with a hurricane that came about because of block in the atmosphere. And that block was northeast of New England. We've seen it in November 1950. We've probably seen it in a few of these other cases, certainly back in February, late February 2010. Blocks are a big deal. Here is a satellite image showing the hurricane as it's making its left-hand turn going into New Jersey. And I just happened to be lucky enough that my flight to Istanbul was supposed to be the Monday night of landfall out of Washington, D.C. I did not go, so I wound up staying at work. So I was lucky enough to actually do the analysis off the East Coast that shows not a 960 low, but a 940 low moving into the southern New Jersey coastline. That was historic. So a very rare combination of a hurricane, which likely would have become a significant winter storm, even if there hadn't been a hurricane there, which sometimes cancel each other, sometimes each out. Sometimes the hurricane weakens because of too much shear when it interacts with the winter system or goes out to sea, but in this case, they seem to work in tandem. So the summary was weather in the case of Hurricane Sandy were such infamous storms of the blizzard of '88 or the Appalachian storm of 1950. The atmosphere sometimes produces something above and beyond what it normally does, and it's in a phase conducive because of blocking. When these blocking patterns occur, the atmosphere gets seriously out of whack. It gets all bollocksed up. And in the process of trying to restore balance, something's got to give, and sometimes the only way it can do that is a storm of historic proportions. And that's what I've tried to show in this presentation, and I think I've just about had it. Thank you.
Well, thank you so much, Paul. Wow, a lot of interesting information, a lot of interesting storms there that I'm sure many of you have experienced and remembered. Again, thank you for taking the time to be with us today. We've got some questions coming in, and we're going to take some time to look at a few of them. Here's one from Ruta out of Maine. She wants to know, why are winter storms not categorized as hurricanes are? And this has been in the news lately, I think.
Oh yeah, it's been in the news because the Weather Channel, my former employer, has decided to categorize them as well. Well, they haven't categorized them, but they have actually named them. The naming I'll leave for another question. The categorizing is actually something I've tried to do on a scale of 1 to 5 with something called the NESIS scale, which basically is a scale that represents how much snow over how large an area affecting how many people. Those three factors, the larger those three factors are, the higher the number, the bigger the scale, the smaller on the lesser end. It's also now being done by the National Climatic Data Center, where they're trying to regionalize a scale that I only did for the Northeast, for the rest of the country. So it actually is something that's being done. It's not easy to do because hurricanes, when it comes down to it, are they're kind of simple systems. They have a central pressure. They often look alike. There aren't that many of them. With winter storms, they're all different varieties characterized by all different kinds of different features, wind, temperature, so it's a much more difficult problem. So we are trying to categorize them, but it won't be in the same way as we categorize hurricanes, simply because there are more of them and more different kinds of them. I hope that answers your question.
Thanks, Paul. Here's another one. Ed wants to know if you can comment on the interaction of upper air wind flow, areas of divergence and convergence, and how they affect the developing storms. You can briefly just mention it.
Typically, the way it works, the type of work I've looked at is looking at upper level jet streams, And those upper-level winds tend to promote certain patterns of divergence and convergence. The way you get big storms is that you've got to increase the divergence aloft, which allows air to evacuate more quickly. That also is promoted with convergence at the surface. Convergence you have in these big winter storms, just like in hurricanes, you need to have that kind of pattern. It's a very complex pattern that develops, but basically you have to have some mechanism that allows air to rise and escape rapidly in order for pressure to drop at the surface. And with all of these big storms, we have to have these low pressure areas that really focus in the moisture, focus in the temperature movements, and those are the mechanism that allows the storm to develop.
Thanks, Paul. Here's one from Jim. He wants to know why they're called nor'easters if they come from the southwest.
But they move northeast. It's not only that they move northeast, they typically affect the northeast, and the winds associated with them when they're moving up the coast are typically from the northeast. So you add all of them up, you kind of get nor'easters.
Okay, let me go to another one here. Is there any correlation of La Nina or El Nino data with severe winter storms? Is anyone finding that out?
There is, but often the relationship is not that clear. It isn't necessarily the make or break factor. Now, if you're in a place like the California Sierra, if you do have a strong El Nino, which corresponds to a greater number of storms coming in off the Pacific, that by definition means more snow in the mountains. However, in a place like the Northeast, where an El Nino may also spell more storms, sometimes we see in strong El Ninos that it's warm. So if it's warm, more storms doesn't necessarily mean more snow. So there are some relationships that have been found. At best, they're a little bit tenuous. At worst, there are other factors that probably are more important.
Okay, Jack has a question. He wants to know if you're familiar with the January 1949 Southern California snowstorm. He lived there at the time in Burbank, about 6 inches, and then even snow in Long Beach.
Actually, I think I am. It's not only in California. That was also a big winter across the western United States as well as the Plain States. I'm not as familiar. I didn't hear about the 6 inches in Anaheim. I know that the record in Los Angeles officially is, I think, about 2 inches, but that doesn't surprise me that some areas, especially with all the elevations, have more, and the fact that Long Beach has actually had some snow, or Santa Monica, is not a very, let's just say, common occurrence. So now that you've mentioned it, I'll have to take a look.
Tom writes us, and his question is why so much zonal flow and mild air across the country this fall?
That's a good question. I've been following it. Right now, we don't have any what I would call good blocks in place. So we're just seeing all of these waves move around the country. I don't have a great answer for that, except that the pattern right now is just not conducive. I'll leave it at that.
Okay, Cindy writes, and she wants to talk about the December 26th, I guess the Christmas 1947 snowstorm that hit New York City. She wanted to know if you had done much analysis on that one.
Oh, I've done a lot of analysis on that one. As a matter of fact, I think I showed a picture which showed this guy with his hands over his head back in 1947. That was the December 26th case. I reanalyzed that case simply because the heaviest snow was over a very small area right in the New York metropolitan area. Turns out that was a developing nor'easter, but there was actually a small-scale feature that caused some enhanced convergence basically right in the New York area that led to what is now the second heaviest New York official snowstorm.
Paul, by the way, where's the picture that you're showing on the screen right now from? Is that,
let me see if I
do you know offhand?
Back up. I will back up. If you just, I think it's right around here. right there.
Okay. Okay. Same. Yep.
Yeah, and there's that feature extending from the low to the northwest, which separated some northeasterly winds in southwestern Connecticut from northwesterly winds. And it was basically that area across western Long Island, southeastern New York, northeastern New Jersey that saw the heaviest snow.
Larry writes in, and he wants to know if you know of what the greatest winter storm to hit the Kansas and Midwest area was.
Well, that's an awfully big area, and just thinking about in Kansas in particular, I don't know. Midwest, you know, I'm not the expert for those areas. I will say that for some of the Midwest, that storm back in February 1st, I guess that was last year, was about as big as they get as well. You know, as much as Chicago, I know their big storm was back in 1967. St. Louis, Missouri, their biggest storms was something around 20 inches as well. Kansas gets they get a lot of stuff. I'm just not all that familiar with specifically what's the worst storm in Kansas.
You know, you just mentioned the Chicago storm in '67, and
Yeah.
Bill had written in and wanted to know why it didn't make your list. He was wondering if it was because it was so localized.
No, it actually wasn't that localized, but I just had to stop somewhere. I didn't even include the February 1st case, and that certainly would have been one to put on the list as well.
Bob from Illinois was wondering that in your reanalysis, looking back at the 1888 and 1922, how were, I guess at that time, how were national and regional isobars created, and then how was the raw data collected without computers and phones back then? How did they put that all together?
Well, that's a good question. I'm not really sure. All they collected prior to the 1930s was basically just surface data. So I could assume at the earliest times it was probably telegraph, and telegraphs have been around, I assume, since the 19th century. So that information was collected. But they were definitely, the Weather Service started taking measurements back in the 1860s, and they were collected officially in a Washington office where they were generating maps of all these data, surface data alone, as far back as the 1850s. So it does go back a long way. It wasn't until the 1930s that we started operationally getting upper air data. It was really around World War II that a real system for collecting upper air analyses began. And that's when we had this whole envelope of surface and upper air observations could start be putting into computers to compute what might be happening. Those experiments didn't start till the 1940s and 1950s.
Cindy writes and wants to know, she's from Minnesota, and why did they get such heavy snow since they're so far from any type of moisture source?
Well, they still have the Great Lakes there, and they may be far from the Gulf of Mexico, but they just happen to be in an area where storms manage to be very intense. Traditionally, it's really along the northeast coast and the west coast where they're closer to water sources like the Atlantic or the Gulf, where it's easier to get a 2-foot snowstorm. The fact is in Minnesota that they won't get many 2-foot snowstorms, but they have so many of them that some of the biggest storms are able to tap into the Great Lakes and the Gulf Coast, and the storms are so intense that they can wring out as much moisture that sometimes gives them that much snow.
Alan was wondering what and you may have mentioned this in your talk, the worst snow or the deepest snow from Superstorm Sandy, where that was and how much it was.
I know I've heard it was around 35 inches in West Virginia. Where specifically, I'm not sure. I'm still working on it.
Okay, then we got some more questions coming in here, and we've got about another 5 minutes. We'll take a couple more as we go through. Let's see. Let me get another one on here. And Bob from North Carolina is wondering what the largest storm for North Carolina. I guess it's hard to know each individual state which is the largest storm. Some of these you might know off the top of your head.
I might know off the top of my head. There are a couple of them. There was one back in 1927. There was another one back in 1940 that seemed to dump, an area of about 20 to 30 inches across the middle of the state. Also, I mean, those are what I would call like the largest storms I've come across. There are other ones as well. I know there was a storm back in March of 1980 that in Elizabeth City dumped about 30 inches of snow as well. But I'd say as far as the whole state goes, 27 and I think 40 are probably considered the big ones.
And here's someone here, lived south of Buffalo, and they wanted to know more about the blizzard of 77, if you remember that. And,
I did.
And could you talk a little bit about that?
Yeah, I could have included that one too. I was actually going to school up in central New York at the time. Personally, I was very disappointed why we missed it. We had some local effect where it came through with maybe an inch or two and no wind. What was really terrible about the blizzard of 1977 wasn't the amount of snow that occurred in Buffalo. I think they officially only got about 4 inches, but it was such a cold and snowy winter that that particular storm, when it came through, was so windy and dropped temperatures so low that I remember them talking about the snow on top of Lake Erie, I guess, was blowing ashore in combination with the snow on the ground and the snow that was coming around, that it was particularly life-threatening. So just not by snow amounts, but because of other factors, the cold and the wind made that a particularly dangerous blizzard.
And you know what I remember back in Christmas time, 1989, along the South Carolina coast. I don't know if you remember that. They got over 20. I drove. It took me. I was driving from Charleston up to Swansboro, North Carolina. It took me almost 8 hours. And what was going on there? Do you remember that one?
It was an exceptionally cold month with many snows. One in particular, I think, hit coastal Carolina, like a foot of snow near Cape Hatteras. It was just an exceptionally cold month, and what was sort of interesting about that was once New Year's came, the pattern completely changed, and where one of the coldest months on record turned into one of the warmest winters on record. It also reminded me, in case I'm neglecting some of the southeasterners, one other storm that I didn't include, and I probably should have, there was a storm back in 1973, I think it was February 9th, where Atlanta was too far north, and a band of 12 to 20 inches of snow fell across central Alabama, central Georgia, South Carolina. It was really a classic big northeast snowstorm superimposed on the deep south.
Wow, that's something there. Hey, here's a question from Eric. Wants to know if there's any kind of period of things, so historic snowstorms, that you might see them in the 50s and they may calm down and you may see them more and more. Is there anything going on with that? Is there anything you can recognize?
Yeah, actually, again, my experience is mostly in the Northeast and more the coastal areas rather than the interior, but in general, the 1960s were sort of a golden period for big snowstorms, in particular in the Northeast. And I would argue that the last decade, last winter notwithstanding, also represents a second golden period where the number of big winter storms seems to be really large. So even though it's been very quiet this year, with the exception of last winter, where our biggest storm was in October, the 2 winters previous to that was just like a potpourri of big storms, one after the other. So for a winter weather freak like myself, it was immensely enjoyable.
Okay, Paul, we're going to take one last question here. And Cindy was wondering if you can go over again just quickly the factors which cause a low-pressure system to deepen off the coast in the mid-Atlantic or the Northeast. Okay.
Now, those factors are rather complicated, but I will say that the biggest factors are whatever can superimpose a strong cell of high pressure over a system associated with a deepening East Coast storm that typically involves what we call a negatively tilted trough with a strong jet region, causing a tremendous amount of convergence at lower levels, rising air. The factors combines with a system aloft that's enhancing the cold air across the Northeast, causes the temperature differences to remain really strong, that also help the air to rise especially rapidly. Those factors can unfortunately be kind of complex, and that's why the situation where they do occur is actually pretty rare. But when they're working in tandem like they are during these historic storms, that's when we often see these really nice comma-shaped clouds developing that are produced by these very strong rising air currents in what we call a very baroclinic or highly differentiated temperature situations where the air can rise pretty fast, and when air is rising fast, you get precipitation. If it's cold, it'll fall as snow.
Okay, we've got one last question. Lisa wants to know if you've heard about the 11 inches of snow that fell in San Antonio in the late 90s. Are you familiar with that storm?
Yes. Actually, I thought it was 13 inches, but, you know, who's arguing about amounts? Actually, I even thought it wasn't the late 90s. It might have been earlier than that, but I could be wrong. But yes, that was also a particular unusual storm. And I actually was in San Antonio when they had a half-inch of snow in about 20 minutes, and I thought that was pretty spectacular seeing it on the Riverwalk. But yes, South Texas had their, well, at least San Antonio had their 13 inches. There's another South Texas, see, I could have shown all of these cases. Back in 2004 that didn't get much headlines because it was the day of the Indonesian tsunami, where Brownsville had their first measurable snow in, I think it was over 100 years, and they had about 13 inches of snow in Victoria, Texas, which is southeast, I think, of San Antonio. So both of those were very historic events.
And you know, as we look, excuse me, as we look at the snowstorms, CoCoRaHS observers out there, it's so important. Your measurements, you know, in different areas, you're helping a lot right now by taking these snowfall measurements. So we appreciate what you're doing, and just encourage you to keep doing that through the winter. Well, Paul, you have an amazing memory, and for
not for other things.
Well, we really appreciate you taking time out of your busy schedule to be with us today. And boy, we learned a lot. Just some interesting stuff here that we can go back and look at. Paul's book, we have a link on our web page, on our WeatherTalk web page, where you can find out where you can purchase that the snowstorms that him and Louis Ussolini put together. We'll have some other references on there. And again, we want to say thank you for being with us today, and we hope you'll join us again sometime. Well, Paul, we're going to wind it up right now, and we're going to tell our folks out there that next month our WeatherTalk webinar will be on January 17th, and it'll feature Jerry Bell of NOAA's Climate Prediction Center. He'll talk about the flavors of climate variability, such as El Nino, La Nina, and recurring jet stream patterns. And finally, to everyone out there, if you would, before you sign off today, take a look at the survey at the end of today's webinar and fill that out. We really appreciate that. So until next time, this is Henry Regis from the Climate Center here in Colorado, wishing you a good afternoon.